Hey everyone, welcome back. So today we're going to be solving Leetcode 875. It's Koko eating bananas, and there's actually a medium problem. Initially, the approach is a bit tricky, but once you get it, it would actually tell you how powerful our binary search is and how we can leverage it. Okay, let's get into the problem. The problem states that you have certain number of piles, and so here are the number of piles that you have, and in each pile you have certain number of bananas like 3, 6, 7, 11. Okay, in the first pile you have third 3 bananas, second one 6, third one 7, and the fourth one 11. And then yeah, you give it another variable h. This is nothing but a number, the maximum number of hours that you can take to eat all these bananas, which is given as 8. Now your task is to find a value such that Coco will eat that much banana within an hour per hour. She should find out that value in such a way that she can complete eating all these bananas within 8 hours. Right. I'll show you an example, but just let me just go to that. But before that, let's try to understand the problem. So Coco has to eat a certain number of banana per hour, and she has to eat all the bananas within 8 hours. So she has to choose the number that she can eat per hour, and she has to eat so many bananas per hour and make sure that all the bananas are completed. That is the problem. Okay, and that value has to be the minimum value. Okay, by that what I mean is, let me explain it to you. So I have 3, 6, 7, 11, right? So what I'm trying to say is, she has to eat a certain number of bananas per hour. Let's consider it as 3. She's eating only 3 bananas per hour. So the first hour she'll complete this banana, which will take her only 1 hour. For 6 bananas she'll take 2 hours. For 7 bananas she'll take 2 hours. For 11 bananas she'll take 4 hours. Okay. Now it costed her 10 hours to eat 8 bananas. Okay, which means that she cannot complete eating all these bananas if she's choosing 3 bananas per hour. Let's say that she's choosing 6 bananas. Okay, this is for 3. Let's say she's choosing for 6 bananas. So 3 bananas she'll eat it in 1 hour, 6 bananas she'll eat it in 1 hour, 7 bananas she'll eat it in 2 hours, 11 also she'll eat it in 2 hours. This I can say that 1, 2, 4, 5, 6. So she's eating 6 bananas within 8. She's completing it within 8 hours. She's completing it in 6 hours, which is less than 8. Okay. So she has to choose a number. Like she has to choose 6 or 4 or 3 or some number where she can complete all these bananas within h hours. Okay. Now one main important thing to note here is that she can eat only certain number of bananas per hour. But that what I mean is, if she chooses to eat 6 bananas, let's say she has eaten 3 bananas in half an hour, does it mean that she can move to the next pile? No, she can't. She has to wait for that hour to get completed so that she can go to the next one. Okay, that's what it means. Okay, that's an important thing. Now our target is to minimize the number of bananas that she can eat so that she can eat all the bananas within a certain amount of time. Okay, now let's see how we can apply binary search on this. Okay. Now, what does a binary search need? What is the first thing binary search needs? It needs a search space. That is nothing but a range. How can I get a range? Okay. Let's forget everything. Okay. Let's just see what is the minimum number of banana that she can eat. What is the maximum number of banana that she can eat? What is the minimum number of bananas that she can eat? Can I say that she can eat minimum of 1 banana? Forget that she can complete or not. Let's not think about that. Let's just see how many bananas she can eat per hour. Minimum number of bananas. She can eat at least 1 per hour. That's the easiest thing. Okay. So can I consider my minimum to be 1? What is the maximum number of bananas she can eat per hour? What is the maximum one? Can I say that maximum number of bananas that she can eat per hour would be nothing but the maximum element in the array? Now you can ask me, why am I saying that? So let's say that she is eating 11 bananas. She'll complete it within 4 hours according to this. right? Because everything lies under 11. So that would be my maximum, isn't it? Can I say that 11 plus 7 would be my maximum? No, it would not, because you have to wait for an hour even though you complete the number of bananas. So what is the point of adding 11 and 7? There's no point, right? So our maximum would just be the maximum element of the array. Okay, so our maximum would be 11. Now can I say that whatever answer that I get has to be in this range, 1 to 11? It has to be between minimum and maximum. Can I say that? Okay. Now that I can say this, forget binary search. How can I check if how can I find the value between 1 to 11? Ideally, what would I do? I'll iterate from 1 to 11. I'll do it for 2. I'll hold the answer 3. I'll hold the answer 4. Again, I'll keep on going. I'll do it 11. This will take you n. Okay. And for each value, what you're doing is you're going. So let's say that just like how we did, for 3 it took 1 hour, for 6 it took 2 hours, for the value 3. For each and every value, you're checking. For 4, if I'm considering my value to be 4, for 3 it is taking 1 hour, for 6 it's taking 2 hours, for 7 it's taking 2 hours, for 11 it's taking again 2 hours, 11 it's taking, it will be around 3 hours, I believe. Yeah, 3 hours. Yeah. So I will check for each value, right? So for each value of the search space, I have to iterate through the entire particular array. So this would give me n. Okay, and if I'm iterating through the entire search space, this would give me into my maximum of range would be 1 into 1 comma maximum of array. This will be my range. This will be my time complexity. This is a lot, right? What if my maximum itself is the array? What if my maximum itself is the maximum length? Right? You can go till 10 power 9. What if it's 10 power 9? Then it'll be n square. Just think about it. N is 10 power 4 into 10 power 9. How big that would be, right? Now we have to optimize that. Okay. Can I think of something wherein we have search space and we have to search for something in that search space optimally? Of course, right? I can use binary search. Okay. Why do I have to iterate through all the values? I only have to iterate through one half. I have to find one half where my answer could lie, and then in that half I need to perform my logic, and in that half also I need to break it into another half into another half until I find the value. Okay. Now, how do I break my half? How do I move my left and right? We'll look into it now. 5, 6, 7, 8, 9 and 10. Okay. What is my mid? 11 plus 1 by 2 is 6. My mid is 6. We just saw, is it possible with 6? Yes, it's possible with 6, because it's giving you a count of 6 which is less than 8. Now can I say that since I have to find the minimum value, my answer would not lie on this right side? If it's possible with 6, it's possible with 7, 8, 9, 10, 11 also. But will my answer be minimum on that? It wouldn't be. So I can ignore this. Now I need to move to the left. Okay. My search space is reduced to this much. Now, with these two as my search space, I'll find my mid to be 3. Is it possible with 3? I got it as 10. Okay, it's not possible with 3. Now what do I do? Can I say that if it's not possible with 3, it's not going to be possible with 2 and 1 also? So this also wouldn't be relevant for me. I can ignore this as well. Perfect. Now I move my low. My low has come here. My low has come here. Now 4 and 5. Initially my minimum value was 6. As I told you, 6 can be my answer, cannot be my answer. I don't know for sure unless and until I perform the entire binary search. Okay. Now I've come to this thing. This is 4 plus 5, that is 9 by 2, that is 4. Let me check with 4. What is it with 4? For 4, this one, 3 will take 1 hour, 6 will take ideally 2 hours, 7 will take ideally 2 hours, and 11 will take ideally 3 hours. What is the answer? It is equal to the h. Okay, now I found a better answer. Can I update my minimum? Yes, I can update my minimum. Now I found the answer. Okay, now I'm assuming that my lowest would not lie anywhere more than this. Now I will eliminate the entire space. Now this was my low, and this was my high, and this was my mid. Now what will happen? High will move from mid minus 1, come here. Now can I say that I've achieved my breaking condition? What would be breaking condition in terms of binary search? Low is less than or equal to high. Okay, if my high is becoming less than low, it doesn't make sense, so we're going to break it, and that's exactly what happened here. High is over here, low is over here. Now I'm broken. Now I can just return the updated answer. I can do this. By this, how are we reducing the complexity? Let's see the time complexity. As I told you, as we're iterating through this entire array, our complexity is n. Okay, into what is the complexity for searching? Okay, can I say that? So what is the complexity for binary search? It's log of n. That is the complexity for binary search, because you're breaking the array into 2 until it reaches 0. So n is going from n to 0 as n by 2, n by 4, n by 8 continuously. So that would give me a time complexity of log n. Okay. Now, what would be my time complexity? Would it be n log n? No, it wouldn't be n log n. What would it be? It would be n into log of, am I searching in the entire array, entire value of n? No. What am I searching for? I'm searching for 1 to max of array. This is what I'm searching for. This is my search space, so this will be my complexity also. So can I say that my final time complexity has been reduced to n into log of 1 max of n. This will be my complexity. Okay, perfect. Now that we understood, let's look into the code. I've written the code for this, and let's just go through it. I actually just wrote it 40 minutes ago, so let's just go through it. Okay, so ideally what we're doing is we are finding the max value. Okay, exactly finding the max value over here. Okay, we're assigning high to be max value, and I told you low will be always 1, because minimum you'll eat is 1. Answer I'm considering to be integer of max value. This is because since I'm finding minimum, I'm initially setting it to integer of max value, and this is my breaking condition, and I'm finding my mid, and I'm calling a function called as is possible. What is this possible doing? Basically the same thing. It's iterating through the piles, and it's checking what is the count. Okay, not checking, basically it's adding the value of count. Now what does this mean? What exactly am I doing over here? What is math.c? Now if the number of banana that I assume is 6, okay, and I have 3, 6, 7, 11, I have 3, 6, 7 and 11, okay, 6. Can I say for 1 hour if I can eat 6 bananas? These are nothing but bananas. I need to know how many hours will it take to eat 3 bananas. So isn't this simple cross multiplication? Will this be 6, 3 by 6? That should be 0.5, will give me 1. Why? What is the point of C? It's going to round off to the next value. So if it's 0.5, it's going to round it off to 1. If it's 1.3, it's going to round it off to 2. If it's 1.7, it's going to round it off to 2, like that. So for 7 by 6, it's going to be 1 point something, it's going to round it off to 2. So this says that I need 2 hours to eat 6 bananas, to eat 7 bananas if I'm eating 6 per hour. Let's validate. 7, can I break it as 1 and 6? So this will take 1 hour to eat, this will take 1 hour to eat. See, I told you, even if it's less than 6, after you eat this banana, after you eat this particular banana, you have to wait for 1 hour before you eat this. It's not like you can directly jump. So this will take 1 hour, this will take 1 hour, so it becomes 2. And that's exactly what I've done over here. This becomes my count. I'm appending my count. If my count value is greater than h, then I'm returning false, else I'm returning true. If it's true, if it's false, let's say, if it's false, I know that if it's false, I know that whatever is on the left hand side is not possible. I have to move towards the right. So I'm moving my loop. Now, else what I'm doing, I'm storing my answer. So I know that this may be my answer, may not be my answer. I'll only get to know once the binary search is done. So I'm loading my answer, and I'll override it if I find a better answer. And I'm setting my high to be mid minus 1. Let's say that I found a value. Whatever is greater than this is not required for me because it's maximum. I'm trying to find the minimum. So I'm going to move this over here. Okay, my high will become mid minus 1. Okay, finally I'm returning the answer. Let's submit it once again, just to show you that it's a working code. Perfect. Let's look into the complexity. Okay, I don't have it, but but we did analyze it mathematically. The time complexity will remain n into log of max of. Perfect. I hope you understood the solution, and I would suggest for you to go through the solution again and try it on. Thank you.